Yes, Kimberly, the Friday classes will be at a normal time. So not this Friday, but the coming Friday. Now, as y'all work through this, we know when it says evaluate, anywhere there's an X, we now just put a 4, right? So we would say in our calculator or in our mind, 4 squared plus 6 times 4. Order of operations, let's do our exponents first. 4 squared is 16. 6 times 4 is 24. Adding those together, I believe we would get 40. Do we agree? Great, that's what I'm seeing in the chat. Well done, everybody. So we just type in 40 as our answer. Now, any questions on this type of thing? Are we good to move on? Okay, great. Thank you. Appreciate that feedback. Now, sometimes there can be multiple variables. I'll give you guys time to attempt that and send your answer in the chat. And definitely there's a strong encouragement to write out your problems, even though it's on the computer screen as you're working through the exam. Perfect, Keith, exactly right. Whenever there's multiple variables, we're just careful, and everywhere there was one variable, we replace it. So everywhere there's an X, we replace it with 4. And everywhere there's a Y, we replace it with -2. Yeah.
This is what I hate to bother you. Is this being taped, this part?
It is.
I'm very, very sick here in Puerto Rico.
Yeah.
Would you mind if I just went back to bed?
Yeah, that's no
Would that
problem.
be okay?
Yeah.
I've already done the other notes and everything, and I'll
Yeah,
get
that's
caught
fine.
up, but I just am not feeling good.
Yeah.
Thank you, Ms. Burr.
Hope
All
you feel
right,
better.
we're back. All right, good night.
Good night. Okay. So as we complete this, we get 4 squared is 16 times 4 plus. Now you can type all this into your calculator at once if you want to simplify. And I think when we simplify, we should get 48 after combining it all together. Okay. Good job, everyone. Now, we also had to simplify, and as y'all saw earlier in our quizzes, or if you haven't taken the quizzes yet, what it looks like is, since it is an online class, you're going to simplify it by hand on your paper, and then you're going to look at the answer choices given and select the correct one. But in this case, I just left it free form. Give everybody a minute to attempt this problem. Kimberly, look at your X terms. Now, what our goal is to condense all the X terms together and all the number terms together. Now, currently, we can't get at this term because it's not yet fully simplified, because what it says is actually multiply this by 2, right? and we haven't multiplied it by 2. So I'm going to distribute this, and it goes to each term. 2 times 5x would give me 10x's. 2 times 4 would give me 8. And now this is simplified where I can rewrite this. And here's where we want to be cautious. We should treat this term as distinctly different than if it had been written like this. Pretend it had been written in blue. Do you see in the blue one, then the minus would go to the 3x and the 6? So that would be written precisely. But in this case, the minus is just attached to the 3x and the 6 is positive. So we'd want to watch out for that. So it's minus a 3x plus a 6. Now the x terms can collapse together and the number terms can combine. So we say 10x's minus 3x's should give us 7x's. 8 plus 6, I believe, should give us 14. So that would be our final answer, and we would select whichever one represents that in the answer choices. Now we've got a bit more practice like this. For our next one, I'll let you guys take some time to attempt it. Remember, you want to distribute everything first before you start combining. So everything should be written in a line before you start combining like terms. I see, yeah. That makes sense, Kimberly. And we will soon have equations, but right now without the equal sign, like you said, we treat it slightly differently. Now, as we're looking here, we would like to get to this term and this term. But currently they're out of our reach because they're actually not what they look like. This is not just negative 5x squared plus 3x, because really we have to multiply it by 2 to really see its true form. Same way with here, really we have to distribute the minus throughout. So we're going to do both of those. We're going to say, okay, the 2 times everything in the first group, distribute the minus. So we get a negative 10x squared plus 6x minus 3x. Minus a negative becomes a positive. Okay. Now that we've got to that simplified term, you combine like terms. Remember, we should treat x squareds as distinctly different from x terms. So we're going to combine the x squareds. I have negative 10x squared plus a 5x squared would leave me with negative 5x squared. 6x minus 3x would leave me still with the positive 3x. And that's what this looks like, completely simplified. Okay, we had a question. I think this is a good question. It said, should we multiply the 2 to the x squared, making it x to the 4th? Now, that's a great question there. The 2 is a multiplier. It's like saying we have 2 of those things. So imagine if I said we had 2 negative 5x squareds. That would be a negative 5x squared and a negative 5x squared. The way those things combine is that would be a negative 10x squared. If we wanted to change the exponent, then it would have to be written like negative 5x squared squared, because then that's repeated multiplication, which would give us negative 5x squared. Which would be a positive 25x to the 4th. So we'll treat exponents as different than constant multiples. So remember, the combining is at the very end. Don't combine too early. Does anybody need more time on the screen, or are we good for the next question? Okay. Give you all a moment to attempt this one. Oh, yeah, I could go back. Now, in this one, we're looking from left to right, and right now this term is completely fine, right? It is exactly as it looks. But the second term really needs to have this -2 distributed to each piece before we can even think about combining it, right? Because it's -2 towards all that. So we're just going to rewrite the first term without change. It's waiting until we can combine things. -2 times x would give us a -2x. -2 times 7 would give us a -14. -2 times -x squared, we would need to remember negative times negative is positive. So that would actually turn into a positive 2x squared. Now we've simplified all the distributions that we could. We now combine like terms. I'll give everybody a second to do that. So we've got our x squareds, our x's, and then we've got a singular numerical term that really can't combine with anything. It just stays by itself. 5x squared plus 2x squared would give us 7x squared. 3x minus 2x would give us a single positive x. Remember, you're free to write it as 1 times x, but generally when we multiply by 1, it's just implied. Minus 14. Now, one of the ways we're going to recognize these are expressions do not have equal sign, right? There's no equal sign here. We treat that different than equations which have an equal sign. Does anybody need more time here? Are we good? Okay. So next we get to actually solving equations. And the key thing that we keep in mind, this is 6.2 material. We really want to stay focused on the fact that we are literally seeing this as a statement. This is saying that the left side, -6 times x, is truly equal in value to 3. What we're trying to find is what is that x value that makes that statement true? And the way we do about that is we get x by itself by moving the terms that are on its side through opposite operations. So since the -6 is being multiplied by the x, we would move it by dividing. So give everybody time to solve this. So we would divide both sides by -6. And when you have one positive divided by a negative, the term stays negative. So negative 3/6 is an answer. And if you want, that would also simplify to negative 1/2. Or if we were typing this probably in our Canvas quiz, we would type in the decimal and we would get negative 0.5. Now, if your answer involves a fraction that the decimal goes on forever and ever, then there'll be instructions in that problem to say, round your answer to so many decimal places. Okay. Oh, perfect, Keith. I saw your answer. That's exactly right. And this is not required on the exam, but remember that this section, you can always check your work. You can plug that value that you found in the original expression. So I would see -6 times -0.5. Let's type that in our calculator, and it's supposed to be equal to +3. So when I type it in my calculator, I do get 3, which is exactly as expected. So that's a way that you can be confident that you got the right answer. Now, sometimes we have to do a little bit more manipulation to get x by itself. And in this case, would we agree at some point we have to move the 9 and the 14? And while technically the order does not matter, one way is going to be prone to more mistakes because you have to be more careful. So I recommend students always move addition and subtraction before they try to move multiplication and division, which means you should move the 14 first. Once that's moved, move the 9. So let's give everybody a minute to work on this on their own. Send your answer in the chat. Perfect, Kimberly. Perfect, Keith. Now 14 is being subtracted, so the opposite of subtraction as an operation is addition. So if we add 14 to the right side, that would counterbalance and cancel the -14. But what's done to one side must be done to the other. Now, -77 plus 14, definitely recommend you have your calculator handy for this exam, is -63. And we have our 9x. At this point, x is almost by itself. We just have to undo this multiplication by 9. Opposite of multiplication is division. So we'll divide both sides by 9. Check that in your calculator, and you would get -7. So we just type in -7. And the good news is you can check your work by plugging in 7 before and verifying you get the right equation. Let's take a moment to attempt the next one. And here I'm going to say let's round our final answer to 2 decimal places. Perfect, Kimberly. Now, as we go through this, you do have two options. If you wanted to, you could distribute the 10 first and then solve. That works. But another way I would say is, what if we, in this case, got rid of this 10? Because that would kind of simplify the left side, because right now the 10 is getting multiplied. But again, you could distribute and then solve. It's just based on your preference. So if instead I got rid of the 10 here, that would leave the left side to just be simply 3x plus 2. 70 divided by 10 is 7. And now I can solve it. If you had distributed, then you would have gotten 30x plus 20, which you can then solve as well. We get the same answer. So I'm going to subtract 2 from both sides. (3x equals 5). Divide 3 from both sides. X equals 5/3. 5/3 is a perfectly good answer, but probably for our Canvas quiz, we would need to type in the actual value, which is why we were told to round to 2 decimal places. So typing that into our calculator, we get about 1.67. Good work, everyone. Let's keep going. Now, in this next case, I think we would describe it in words as we need to be a little cautious because there are multiple variables, right? And not only that, do we see the variables are on either side? So we would want to make sure that we move the easiest one. You could move the 9 over by subtracting 9y. You could move the 5 over by subtracting 5y, which is going to be maybe better for us. Both would work, but one will probably be easier. I think the 5, right? Because if we subtract the 5y over, we're not creating a negative term. But if we subtracted the 9y over, that would become negative. So I'll give everybody time to work on that. Correct, Caitlin. That's right. Good job. So here I will move the 5y over. It's currently positive, so I'll subtract it because my goal is to get to y's on only one side. That would leave a negative 2y on the left side. 9y minus 5y is 4y plus 2. Now that we've got the y's in a single place, we're kind of acting as before. We want to get y by itself, so I will first subtract 2 from both sides. (4y equals negative 2 minus 2 is negative 4. Common error there would be to make it 0, but if you type it into your calculator, you can be sure it's negative 4. Negative 4 is being multiplied by y, so we're going to divide both sides. And we get y is equal to, oh, and this was a positive 4. I copied it wrong. So negative 4 divided by 4 is a negative 1. So good job, Kimberly. Take a moment to look at our next one and think about why this one is slightly more difficult than the previous ones. We can still totally handle it, but what would we want to make sure we do first? Kind of outline the steps in words. Perfect. We would first distribute. That's exactly right, because we can't really treat these. So I would distribute. And then once we've distributed, do we agree that we have multiple y's on either side? So probably in words, I would tell myself, get the y's to one side, the numbers to the other. So let's take a moment to distribute and start to solve this on your own. If you get an answer, send in the chat. Probably around 7:11, we'll discuss it together. Caitlin, I think that's correct. Just thinking through myself. We'll see, but I think that's correct. So when we distribute, we should get a 9y minus 3 on the left side, 12 plus 12y on the right side. My goal is to get the y's to one side, numbers to the other. So I'm going to move the 9y over. It's currently positive, so I'll subtract it. Always do the opposite operation. And that would leave us exactly with a negative 3 on the left side and a 12 plus a 3y here. So now we're going to move the numbers over. So I'm going to move the 12 over. It's positive, so I'll subtract. And that would leave me with negative 3 minus 12 is negative 15, equal to 3y. Divide both sides by 3 because it's being multiplied. And that would give us y equals negative 5. And particularly if time permits, remember you can always check your work by substituting that value back into the original expression and making sure you get a true statement. Any questions here before we move on? Good. Now our last one, as I look over it from left to right, I'm going to be a bit more cautious because I notice I have 3 different x's on different sides of the expression, and also this term would need to be distributed before I can really solve. So give everybody a minute to work on that. So as we distribute our term, we would get a minus 4x and a minus 36 on the left side. Now the minus 4x would combine with the positive 5x to just give us a single positive x when we combine like terms on the left. And at this point, we're kind of back into the old procedure. We see we've got x's on both sides. So in our mind, we're thinking x's to one side, numbers to the other. I can move either, but I'm going to move the smaller one, so I stay positive. Two x minus x is just a single x. minus a 3. Okay. So then I would add a 3 to both sides. And we would just get that x equals negative 33. So in this case, we first distributed, then we combined like terms, and then we got to an equation that we can solve in general by moving all the x's to one side and the numbers to the other. Now let's look at our next example. And if you have a question, Caitlin, let me know. I'd be happy to address it. Kimberly, I think it's slightly different. If I'm doing it correctly. Now, as we're working at this problem, if our goal is to solve x, I notice that I can't really access x in either of these terms because it's not yet simplified. The first one, we have to distribute the minus sign throughout. And in the second term, we've got to distribute the 4 as a multiplier. So let's simplify the right side first, and then we can worry about combining like terms and actually solving. Negative times x is a negative x. Minus a negative becomes a positive. That's a key thing to remember. So minus a negative 1 is a positive 1. Plus 4 times x is 4x. 4 times negative 6 is a minus 24. And all of this was equal to 100. So we keep in mind that we were just manipulating the right side, and we keep writing the left side as it is until we're ready to work with it. Now in this case, unlike before, do we see in our earlier example, we had 2 x's, but they were on opposite sides of the equal sign? But in this example, we have multiple x's, but they happen to be on the same side of the equal sign. So they would just combine naturally without even moving them. So we think about negative 1x plus 4x's would leave us with a positive 4x's. Sorry, positive 3x's. 1 minus 24 is a minus 23. All of that was equal to 100. So in this case, we are going to solve for x. We have a single x. We're going to move the 23 first. Since it's negative, we'll add it to both sides. That leaves us with 3x here equals 123. So now we say 123 equals 3x. To solve, 3 is being multiplied, so we'll do the opposite, we'll divide. And our calculator, 123 divided by 3 would be 41. And notice we do treat it differently when the x's are on the same side, right? Because then they can combine like terms. Any questions on this example? Okay, we'll keep going. Now, another thing that we learned in 6.2 is sometimes there are equations that never should have been set equal to each other. If whenever you're solving the equation, you get down to a demonstrably false statement, what that implies is that there's no solution. Now, other times when you're solving an equation, you would get down to just a true statement, and that means there's infinitely many solutions. So take a moment to solve this equation, and based on the result you get, whether it's a true or false statement, identify if there's no solution or if instead there are infinitely many solutions. Perfect, Kimberly. Exactly right. Now, I think we'd see in this case, we can't really solve until we simplify the right side, right? We have to distribute that 4. So I would rewrite the statement as 4x plus 5 equals, now 4 times x would give me 4x. 4 times negative 2 would give me a negative 8. Now, if I'm going to try to move the x's to one side, the 4x is being positive, so I would subtract a 4x from this side, trying to move it to the other side. And as I do, my goal was just to cancel it from this side, but since I had the exact same value on the other side, do we agree that cancels as well? So we get down to 5 equals negative 8. We ask ourselves, is that true? Is 5 really the same as negative 8? Good. No, definitely not. That is false. And whenever you get a false statement as you're solving the solution, that means that really there's no solution. This is a case where these equations should have never been set equal to each other. There is no such x that would ever make 4 times x plus 5 equal to 4 times x minus 2. Now, a similar case, except instead of getting to a false statement, is when we get to a true statement. Take a moment to try to solve this and identify whether we would have no solution or infinitely many. Perfect, Kimberly. Now, as we solve this one, again, we do have to distribute first. The 3 goes to the x and the 2 as multiplication. That'll give us a 3x plus 6 on the right side, 3x plus 6 on the left side. And as I tried to move the x's over to one side, I'll subtract a 3x. But it just so happens that that cancels perfectly on both sides. And we're left with 6 equals 6. This is true, right? 6 is equal to 6. So that's a true statement, which means there's really infinitely many solutions. And we talked about that. And oh, good question. Do you really need to solve this far for this? No. If you recognize one is a constant multiple of the other, it's guaranteed that it's infinitely many. So for instance, here, once we recognize that a constant multiple or the same thing in disguise, right? Same thing equals same thing. Of course, that's true. So that brings us to 6.3. Now, 6.3 is when we had word problems. So based on verbal descriptions, we had to create equations and figure out what to do with them. One of the things we talked about is percentage. Now, we're about to give you time to work on this problem, but just a small primer. Remember, when you're finding the percent of a number, the basic formula we want to remember is the percent written as a decimal times the number given in question. That's how you find the percent of a number. So let's all take a minute to read our first question and work on it. And we'll discuss around 726 or 727, the solution. So Kimberly, think of setting up an equation. So you found 30% of 28, but 28 is the result of decreasing the value of 30% by some unknown value. And we're looking for the unknown value. So as we work through this, one thing we'd want to keep in mind is whenever it talks about percent decrease or increase, we're not really going to be working with 30% directly in the problem, because we didn't find 30% of the original value, right? It didn't say it was decreased to 30% of the original value. It said that there was a 30% discount. So how much of the original value is remaining if you discount it by 30? Would we agree that means 70% of the original value remains? Good. So that's the key thing we want to think. Decreasing by 30% of itself means you still have 70% of the original. And we don't know the original price. A good rule of thumb is things that you don't know, give variable names to. Let's just use X. So I'm going to call the original price X here forward. Now, what was the result? Is 28 the original price, or is it the after discount price? It says it's the after discount, right? Because it's the result of the discount. So I could set up this word formula. 70% of the original price ends up being $28. Now, just so we can kind of check our work, should we expect our unknown value to be greater or less than 28? Greater, right? So if we get a value that's less, we're going to kind of second guess our work. We're going to say something's off because the original price should be higher. Now, once I've realized that decrease by 30%, this is the big trick. Realizing that that means it's 70% of the original. So always try to phrase it in terms of the original. 30% decrease is 70% of the original. Then we can set up the formula that 70% as a decimal is 0.7. To find the percent of a number, you just take the decimal, the percentage written as a decimal, and multiply it by the value. Now, we don't know what the value is, but I'm just calling it x so I can work with it. And that would set up this equation. And for these problems, I would say the part that we should be most careful about is setting up the equation. Once we've set up the equation, would we agree it's kind of like our last section in terms of solving? So it's multiplying by 0.7, so we would divide both sides by 0.7. X equals 28 divided by 0.7, which if you type that into your calculator, you should get 40. So in this problem, we did not know the original price. We just know the result of the discount. So we had to set up an equation to find the original price. But if it had just said what's 70% of 60, do we agree that would just be 0.7 times 60 and we get our answer? There's no equation to solve there. Any questions that we could answer here? Okay, let's continue then. Give everybody a minute to read through. Remember, with the word problems, I recommend you read it once at first, get the idea, and then read it again looking for things you don't know. The things you don't know, you're going to want to give variable names to. Or the things that are changing, either unknown or changing. As you read through the second time, think about what quantities, things that could be measured, what is changing in this problem. There's two. Just saw your comment, Caitlin. I think that's probably a common feeling. Now, have y'all had time to read through it twice? Anybody need more time? Okay, I'll give it a bit more time for everyone. Now, I think these problems will go more efficiently if we have a pattern. Your pattern is you read it through the first time, just to kind of get the basic ideas in your mind. And then you read it through a second time to extract more information. And particularly the information we want to extract is we want to be able to write equations, but equations relate quantities, and quantities is just a phrase for things that can be measured, things that are changing. So before I start to write equations, I'm going to try to describe in words what's changing in this problem. Can anybody name one quantity, either out loud or in the chat, of something that's changing based on the verbal description? I think I saw somebody mouth the year. Yeah, year is changing, right? The age, perfect. So we've got two things. As time passes, hasn't it been described to us that the age of the car seems to increase over time as well? So not only are these two things changing, but they're linked in such a way that we could write an equation talking about how they're linked. So I think the first step is to recognize, okay, my quantities are time that passes since 2014 and age of car on the road. Now I'm going to write that out and I'm going to give them variable names. I'm going to let T, and you can choose any letters you want. I try to prefer to choose letters that remind me of what it's representing. T is the time in years since 2014. Why do I say 2014? Because everything that I was given was referenced to 2014. Because it said at 2014, this was the average year. At 2014, this is how it was growing. Everything is in reference to 2014. And then let's say A for age of car, or average age of car. Okay, now at 2014, does the average age of the car just start out at 0 and starts growing from there by 0.1 each year? No, right? Where does it start? $11.3, right? So at 2014, it's starting at 11.3, and then we would agree in words the next year it adds 0.2, so we'd be at 11.5. And then 2 years after, we'd add another 0.2, and we'd be at 11.7. This idea of every year adding 2, would we agree that's repeated addition? But how else do you express repeated addition? Multiplication, right? This would be the same thing as saying, take the starting period, and every year that passes, add 2 to it, which is the same as 0.2 times t. So notice we've set up an equation that relates time and age. And how do you know that it should be in terms of time and we get age? Well, we ask ourselves what happens first. Time passes, and as a result, I guess technology's improved, who knows what's happening, and the age of the car is increasing. Okay, now we've got our equation. This is probably, that's where we should really be careful. Of course, we should be careful all the time, but setting up the right equation, even if you do correct work afterwards, if you have the wrong equation, do you agree you're getting the wrong answer? So we want to make sure we set up the right equation, because even if we do our work correctly after, if it's with the wrong equation, it's no use. Now, what are they asking us to answer? What additional information do they give us? An age or time? Read through the problem. Would we agree they gave us an age? They gave us the age of 12.3. And aren't they wanting to know what time this occurs? So they've given us part of a linked pair. So I would say 12.3 is my age, but it has to fit this model. So I could solve using algebra to get t by itself. Now this collapses to some of our earlier problems of solving an equation. Let's all take a moment to solve for t. Perfect, Kimberly. So here we would subtract 11.3 from both sides. That leaves us with 1 equals 0.2t. Divide both sides by 0.2. And we get t is 5 years exactly. Great. So with these problems, remember, the real key detail is setting up the right equation, and you do that through process, reading it carefully, thinking about what the changing quantities are. Let's take time to read through this twice. First time, just general reading. Second time, trying to identify what's changing or related. And we'll discuss this about 7:41. I want to give time for people to think about it. I saw it was mentioned in the chat how forming the equations is the most difficult part, and I think that's true for everybody. The forming equations is the difficult part. And we'll try to practice and discuss that together some. Now we're going to do this in pieces. Let's first talk about the quantities involved, and we'll give them labels, and then I'll give you guys a second to try to form your equation on your own. So what seems to be changing here? There can be multiple things. Births and death, anything else? What about time? Because I do see the phrase each day, right? So I don't know if we will use that, but I'm going to write down each of the variables. And just because I write it down doesn't mean I have to use it later. We'll see as we kind of explore this further. So I'm going to say, let's let B be the number of births. Let's let D be the number of deaths. And let's let T be the day. Days passing. I'm not particularly sure I need the T yet. I'm just writing that down because I realize that is changing. Okay. Now I'm going to read through the problem, and then I'm going to give everybody a little bit of time to try to come up with the equations on their own based on these variables. And then we'll discuss the equation and we'll solve the problem. But we know writing the equation is really the crux of this issue. So each day, the number of births in the world exceeds. What do we think about when we hear the word exceed? Greater, right? So it should be higher. It doesn't just exceed it in general, it exceeds it specifically by twice the number of deaths by 72,000. So it's not exactly twice, but if you twice it and then add 72,000, that's kind of the relationship. So remember, we're going to translate these verbal descriptions into equations. If the population increases in a single day is 228,000, determine the number of births and deaths. Now, for a population increase, that would be net increase, right? All the deaths versus all the births. Does that make sense? So births minus death is population increase. So I don't know exactly what this will take a form of, but I might write that out once I recognize that population increase is equal to number of birth minus number of death. That seems important. Okay. Now, I'd recommend that you take the next minute or two to read through. And what I'm highlighting in green, our first statement should be translated into an equation. And then they gave us additional information. Any information they give us should be translated. The additional information is they told us population increase was this amount. So they've given us two linked pieces of information. Write those corresponding equations. Okay. So let's translate the one in green first. The number of births, okay, is twice the number of deaths and exceeds it by 72,000 more than that. So I might say like 2 times the deaths plus 72, that would be equal to the number of births. right? Because this is saying the number of births is twice the number of deaths plus 72 extra. And then the blue statement is population increase. Well, I know population increase is birth minus death. So the population increase in a certain day is 8,000. And everybody's saying the word thousand, but it's always in words. So I'm just going to write it as 228 and know that my value is in thousands, right? So I don't have to write a ton of zeros. That equals the number of births, B, minus the number of deaths. And in this case, I've translated everything, and I see I did not use my time as days passing. So I thought maybe that would come into play, but it didn't. So not necessarily everything we write down has to be used. So I'm going to cancel it out for now so I don't get distracted by it. So we have our equations. Now, you might ask the question, and fairly so, how do you know how many equations that I'll need? There's always a formula. However many variables you have, you need that many equations. Okay. So since we have a variable, an unknown birth and death, we need at least 2 equations to be able to solve for it. Now, this is a bit different than what we've done before because we can't use just single algebra manipulating a single equation to solve because we can only solve an equation in one variable. Would we agree the top equation is in 2 variables? The bottom equation is in 2 variables. So neither of these can be manipulated on their own. However, we could substitute one thing into the other. For instance, isn't birth literally equal to 2d plus 72? And if I substitute this in the other equation, then I'd get something all in terms of a single variable. Instead of b, I'm representing it alternatively as 2d plus 72. Now, I do recommend just by practice, when you're substituting something with multiple terms, keep it in parentheses in case you have to distribute. Now, in this case, it's so simple, we don't have to distribute, so I can drop the parentheses. Combine like terms 2d minus a d would give me a single d plus 72 equals 228. So we can solve for the number of deaths. We'll subtract 72 from both sides. And we get the number of deaths is 156,000. I add the 1,000 because I know my units are in 1,000. And once we know the deaths, could we quickly find the births? Because the death is 2 times the deaths plus 72 would give me the births. So 2 times 156 plus 72 by above is supposed to give me the number of births. That's 384,000. Good news, just as before, you can be sure if you got the correct answer. You can plug both of these into the equations. So for instance, 2 times 156 plus 72 does equal 384, the number of births. Let's plug it into the other one. The number of births, 384, minus 156 does indeed give me 228. How are you feeling about this one? Any questions? We good to move on? Okay. I think my key hint to everybody is just take your time in these problems. Give everybody a moment to read this next one. Remember, think about what are your changing quantities? What are you going to call variable names? So I think our changing quantities is the value of the car and time, right, in years. So I might say maybe V is the value of the car. T is time. And we know the car starts at 24,000, and every year that passes, it loses $3,000 by this estimate. After how many years will the car's value be 9,000? So let's first set up an equation that relates value and time. The value should start at 24,000. And each year we are depreciating, which is losing, makes us think of subtraction. 3,000, but repeated subtraction of 3,000 is the same as 3,000 times t, right? Because repeated addition or subtraction can be written as multiplication. So this is 3,000 t. Now that we have this equation, what additional information have we been given? We've been told that the value at the point in question is 9,000. So we need to set that equal to v and solve for t. Because if you get down to an equation in one variable, you can solve. So we get 9,000 equals this. Subtract 24,000 from both sides. That would give us a negative 15,000 divided by negative 3,000 equals negative 3,000 t. Undo the multiplication by dividing. And we would get 5 years. Okay, let's continue on. We have 2 more word problems to practice. Give everybody a few minutes to think about this one. Perfect, exactly right, Kimberly. Now, in this case, in words, would we agree that we're trying to see when company A's price equals company B's price? So if I write my equal sign, if I can find a way to write like company's A's price to one side, company's B's price to the other, then all I have to do is solve it. So with price or cost, anything like that, I always like to think of the word formula fixed cost plus variable cost. Would we agree for company A, the fixed cost is the $20 that you have to pay up front plus $10 for each hour? Okay. And for company B, their fixed cost is higher, $40, but their variable cost per hour is lower. Since we're wanting to know where they're equal, we could just immediately start solving this to get H by itself. I'll give everybody a minute to do that. Now here we have variables on each side of the equal sign, so we want to move variables to one side, numbers to the other. I'm going to subtract a 5h from both sides. Move the numbers to one side, so subtract a 20. Five times h equals 20, so we can divide both sides by 5. And we get h is just equal to 4. So after 4 hours, they are the same price. So after 4 hours, so at first, would we agree that company A is cheaper because they have a lower initial price? But if you rent it for long enough, since they have that higher hourly charge, they'll eventually overtake company B's price. So if you wanted to rent it for only 2 hours, use company A. But if you wanted to rent it for 8 hours, then company B would be more cost effective. Now our last problem from 6.3 before we go to 6.4, our inequality material, is this word problem. It is a lot of large numbers, but remember the calculator can take care of the large numbers. Now, as we're reading through this one, would we agree what's changing is it seems to be as time is passing, the populations of Greece and Belgium are changing. And what are we looking for? We want to know when they're the same. So this is kind of like our company A, company B problem, right? We've got two different rates of change, and we want to know when the result will be equal to each other. So in words, if I could express the Greece population over time, so related to our time variable, and if I could set it equal to the Belgian population, that's really what this is looking for. So allow yourself to think through it in words first before we get caught up in the formulas. Now, what's happening to both populations? Going up or down? Down, good. Now, one is starting higher and going down faster. The other one is starting lower and going down slower, right? So would we agree that in 2000, Greece started at 10,600,000, but each year that passed, they lost 28,000 people. So I should have my starting point minus what I'm losing, which would give me 10,600,000 minus 28,000 each year, which I'm just going to express time as t. Repeated subtraction is multiplication by that factor. Equals, if everybody would take a moment to write out Belgium's population growth over time as an equation. Perfect, Kimberly. So in this case, we start at 10,200,000. And we're losing population less rapidly. We're only losing 12,000 a year. And they were just saying, at what time will it be the same? So do we agree in the end, we're looking for a time value t? Now we have an equation. How many variables are in this equation? 1. So you can solve an equation in one variable using our algebra. Take a moment to solve this equation to get t and type your answer in the chat. Watch out as you type in your calculator, you don't type too many zeros. That would throw your answer off. That happened to me. Perfect, Kimberly. So here I want to get the variables to one side, numbers to the other. Both of these terms that involve the variable are negative. So would we agree that in the end, I'll have to add it over? So I might as well add over the bigger number to turn things positive. So out of preference, I'm going to move the 28,000 first. I believe that should leave me with 16,000. T positive. Okay, now we're going to solve for t. We're going to move the numbers over first. So we're going to subtract the 10,200,000. And that would leave us, I believe, with just 400,000. Equals 16,000 t. So if I divide both sides by 16,000, I'll get t by itself. And t, typing that into the calculator carefully, would be exactly 25 years. So after 25 years, the populations would be momentarily equal if this rate holds up. Are we feeling a little better about writing the equations? No? Okay. Would y'all like more practice about that? Maybe you can type what you're saying, Caitlin. I was having trouble lip reading. I think the key thing is to try to focus on what are the quantities, give those labels. And one good thing to note is every section in the exam, it can't be perfectly equal. That's really hard to make it perfectly equal, but I will try to make it where, there's 4 sections for this chapter. No one section is going to take up a disproportionate amount of points. So it's not like this section will be worth tons more points than the rest. I'll try to distribute it equally. So we'll go forward then to 6.4. This is our most recent material, Inequalities. Now remember, graph means draw the number line. And how y'all see this in the Canvas quizzes is you should do it on your paper. And then we will select the correct answer from the options given. Now this is a notation that our textbook uses. I don't happen to use it in our class, but just so you'd be familiar with it if you see it on the homework. This is just saying the set of all x values where x is greater than or equal to -2. So pretty much you can just focus in on this. It's just a fancy way of saying when x is greater than -2. Does that make sense? Okay. So we'll draw our number line. Give everybody a minute to attempt these two on their own. So we have -2 is the point of interest for our first one, and it says x should be greater than -2. We notice there's no equal to, so immediately we do an open circle. And we see that this splits us into a few different sections. You could be before -2, at -2, and greater than -2. We specifically want to just be greater than it. So we're going to do the open circle to show that we don't equal it, but we're okay to be anything larger than it. Now the next one is very similar, except do we see it's greater than or equal to? So the main change is here at -2. We're going to have a solid circle showing we can equal -2, and we can also be everything greater than -2. So watch out for that greater than or equal to or just greater than. Now we also have to be able to solve inequalities. So in this case, you're working to get the variable by itself. Give everybody a moment to solve this. Remember, the key thing is if you multiply or divide by a negative number, you switch the direction. Everything else is the same as just regular algebra. Now when we solve, x is currently being subtracted by 5, so we do the opposite and add 5 to both sides. That would give us that x should be greater than or equal to 6. So I label my point of interest 6. It says I can be equal to, so I shade that in. And then in terms of greater, I should be above it. So I'm going to shade to the right. And that shows any of the x values that live to the right of 6 are a solution. Take a moment to solve the next two and graph the inequality. Now in our first one, it was 6 times x is less than or equal to 18. To solve for x, since it's being multiplied by 6, we can divide by 6. Since it's a positive number, we don't have to worry about switching the signs, and we will get x is less than or equal to 3. Mark 3, you can be equal to, and then less than is the section before it. Now our next one, we want to get x by itself. Just like we've done with our other algebra, we move the addition first. So I'm going to move the plus 2 over by subtracting 2 from both sides. That would give me 3x is strictly less than 12. I can solve for x by undoing the multiplication of 3 by dividing by 3. And that would give me x is strictly less than 4. So we mark our 4. Since it's strictly less than, we do an open circle. And then everything below 4. Now for the next one, you see that we have a fraction. We know we want to get rid of a fraction. So you can get rid of the fraction by multiplying, if there's multiple fractions, by the least common denominator. If there's just one, just multiply everything by the denominator there. So we are going to multiply both sides by 2. And we get x should be greater than 6. Not equal to, so we do open circle, and greater than should be after it. Any questions that we could address so far? Or are we following pretty well? Okay, great. Thanks for the feedback, everyone. So let's continue. Sometimes there's variables on both sides of the inequality. So just as with equations, you move variables to one side, numbers to the other. And we remember the one caveat that if I ever in the process of solving multiply or divide by a negative number, I have to switch the direction of the sign. Why don't we all take a minute to solve these two? The first one and the second one. We'll discuss their solutions around 8:13. Okay. Now here I have x's on both sides, so in my mind I'm thinking x's to one side, numbers to the other. Strategically, I think it'd be easier to move the single x by subtracting an x over than it would be to move the 2x. So 2x minus x is just x plus 9. Get x by itself. The only thing that's stopping it is this adding 9. So if we subtract 9 from both sides, we would just get x should be less than or equal to -7. Now remember, adding and subtracting doesn't change the sign, just multiplying or dividing by a negative number. So we've got our -7. We can be equal to it, and we want to be less than it. So to be less than means to be to the left. Okay, now our second one, I see I've got x's on both sides, so I'm going to move x's to one side, numbers to the other. Specifically, I'm going to subtract by the 2x since it's positive to move it over. That would leave just an 11 here. 3x minus x is just an x. So to solve for x, we could add an 8 to both sides to counterbalance the -8. X is less than 19. So we mark 19, open circle because it just said less than, not less than or equal to. And then we shade like this. And would we also be familiar if it was like this? kind of shading with the highlighter, we know that's also, I'm just indicating this is the shaded section. So it might look kind of more like a highlighter than scribbles. Why don't we take a moment to solve this next one? I would tell you guys to be cautious. There's one trick here. Would we agree x is almost by itself? Just the minus x, that's the same thing as saying minus 1 times x. We'd want to be able to see that. We just don't write the minus 1 because it's implied. So negative x is negative 1 times x. So if you want to get x by itself, I'll need to divide both sides by negative 1. But when I'm working with inequalities, that kind of sends up alarms that I should reverse the order of the sign. So I do that first just to make sure I don't forget, because I divided by negative 1. Negative 3 divided by negative 1 is a positive 3. Negative x divided by negative 1 is just a positive x. So now we get our statement x should be less than or equal to positive 3. And the key thing here is I did switch the sign after I divided by a negative number. So I mark my 3. I can be equal to, but I also need to be less than, or I could also be less than, so I shade before. Let's look at our next one. I'll give everybody time to work this one. Now, as we work through this one, I notice that it's an inequality and there are x's on either side. And before I can even start moving the x's, I do have to distribute to simplify each term, just like we did with the equations. So I'm going to first distribute the negative 2 to the x and the negative 4 on the left side, and distribute the 5 to the 1 and the negative 2 on the right side. So that would give me 7, doesn't change, but negative 2 times x is a minus 2x. Negative 2 times negative 4 becomes a positive 8. Negative times negative is positive. That's less than 5 times 1 is 5. 5 times negative 2x is a negative 10x. Now, would we agree the right side is fully simplified? But the left side is not. Specifically, we could combine the 7 and the positive 8, right, to be a 15. So we'll want to do that. 15 minus 2x is less than 5 minus 10x. And now our idea is to get, now that the left and right sides are fully simplified of themselves, we're going to move x's to one side, letters, numbers to another. You can move the 2x or you can move the 10x, but do you see if you move the 2x, you're still going to have a negative 8x left over. But if you move the 10x, adding a 10x to both sides would create a positive 8. So we'd save some time by adding 10x over. That leaves us with a 5 on the right side, 15 plus 8x on the left. We'll subtract 15 from both sides. (8x) is less than negative 10. Finally, to get x by itself, we would divide both sides by 8. So x is less than, we know it will be negative, but specifically, that's negative 1.25. when we evaluate in our calculator. So we just draw our number line. We want to be strictly less than negative 1.25, open circle, and all the values before. How are we feeling so far? Good. Okay. We'll continue on then. Would we agree the troublesome part of this expression is the fractions? Okay, we don't want to deal with fractions, so our first goal is to get rid of them. Whenever there's more than one fraction, remember you get rid of them by multiplying everything by the least common denominator. Think about what the least common denominator would be and take that first step on your paper. So remember, the least common denominator is just the least common multiple of the denominators in question. The least common multiple of 10 and 5, I believe, would be 20, right? You could also use 50, any common multiple. No, it's 10. I was doing that wrong, right? It's 10. 10 is the least. Now, if you use 20, anything would work. It would just make it a bit more complicated. So 10 is the least common denominator. So to make sure I don't miss anything, I'm going to include everything in parentheses here before I multiply by 10 to ensure that I distribute to each of the terms, because that is a key detail. So I'm going to write 10 times the left side in parentheses should be greater than or equal to 10 times the right side. What's done to one side must be done to the other. And now we distribute this to both terms on each side. So 10 times 3x over 10 would be 30x over 10 plus 10 is greater than or equal to 10 over 5 minus 10x over 10. And if we've chosen this correctly, all these fractions will simplify because 30 divided by 10 is 3. 10 divided by 5 is 2. 10 divided by itself is 1. So we now get to this inequality that does not involve fractions, and we solve as normal. Why don't we all take a moment to solve? X is to one side, numbers to the other, so we'd add an x to both sides. 4x plus 10 should be less than or greater than or equal to 2. Rewrite that. We're going to subtract 10 from both sides. And we would get x should be greater than or equal to negative 2. Now our next one is what we call our compound inequality. Oh, do we need more time? Okay, sorry. The next one is what's called a compound inequality. And we know we can solve these by just remembering that now we don't have 2 sides to keep equal. We have 3 sides to keep equal. So it's done to one portion must be done to all 3 portions. We want to get x by itself, but it's currently being added by 5. So we can get x by itself by subtracting from 5. But if it's done to this portion, It has to be done to all three. We just get x. We haven't multiplied or divided by negative numbers, so the signs stay in the same direction. 11 minus 5 is 6. 7 minus 5 is 1. And if we're going to graph this, it's saying x should be greater than 1, but less than 6. So open circles for both, and then think where's... Oh, did I write it wrong? It's 2. That's okay. I was like, what does that symbol mean? Yes, thank you, Caitlin. That's correct. That should be 2. 7 minus 5 is indeed 2. So that should be a 2 there. Thanks for that correction. We want to be between 2 and 6. So that would be this middle section. Oh. I'll try not to, Caitlin. But great. So remember, when there's multiple inequalities, you just treat it the same, except now there's 3 pieces that have to move at the same amount. Let's try one more, except now our middle term is slightly more complicated. We've got to move a few more things. I'll give everybody a minute to work on this themselves. Okay, now in this case, just as before, we're going to have to get the 4 and the 3 away from the x, but we do move the subtraction first, so we're going to get the 3 away. We are currently subtracting 3, so if we add 3 to this term, it will get rid of it there. But what's done to one side must be done to all the sides. So that would leave us just with 4x. We haven't added or multiplied or divided by a negative number, so the signs stay the same. 19 plus 3, I believe, is 22. 3 plus 3 is 6. Now we'll divide everything by 4 to get the x by itself. Now 6 over 4 in our calculator, I believe, should be just 1.5. 22 divided by 4 is 5.5. Now, as we graph this, we just need to pay close attention to the fact that we could be equal to 1.5 or greater, but we do need to be less than 5.5. So solid circle for 1.5, open circle for 5.5, and we're between those values, so we'll shade here. We good on that one? Okay. Let us go to our last problem of the Chapter 6 review. Why does everybody take a minute to solve this on their own? Now our goal is to get x by itself. We will have to move the multiplication of 1/2 and the subtraction by 4, but we are going to move the subtraction by 4 first by doing the opposite of adding 4 to both sides. No, all 3 sides in this case. So I believe -6 plus +4 is -2. -3 plus +4 is 1. Now we know we can get rid of 1/2 by multiplying everything by 2. So I'm going to multiply everything by 2. That cancels that, and we just have our x. And I did lose the or equal to when I copied over. That should be or equal to. 2 times -2 is -4. 1 times 2 is 2. So we get our inequality, and now we just have to draw our number line. We have -4 and 2 are our points of question. We could be equal to 4, but not equal to 2. And we could be everything in between. So that would look like our answer. So that brings us to the end of chapter 6, exam review. Now remember, these are not necessarily the exact problems on the exam, right? These are just additional practice problems in addition to what we've gone over in the notes and things like that. So just see these as additional review problems of the main topics. We do have 9 minutes left of class, so if you have questions, stay behind and I'll be happy to address them. If not, do feel free to leave early. And remember, our 6.1, 2, and 3 quiz are due this Saturday evening at midnight. So definitely don't miss those. Bye, Kimberly. Bye, Caitlin. Bye, Keith. Now, does anybody remaining have questions? Okay, so there's no questions, so we'll end the class.